Imagine we have a piece of paper, or you can take a real piece of paper if you want, and you draw a line, and you draw two points on this line. And we're going to do a small exercise. You are going to find the point which is between those two. So you don't have to be super precise, just more or less. So I find this point here. And now I'm going to repeat this again between the last point I draw and this one here. So I find this point. And again, I'm going to find a point between these two. So it's here. And then the next one is here. And the next one is here. You can see that the distances here get smaller and smaller and smaller. If we would animate an object, for example a circle, you can see that the steps at the beginning are large and then they become smaller and smaller and smaller. The result would look something like when a bicycle is braking. So you're initially moving fast and you come to a stop. Slowly you reduce the speed until it halts. We can simulate this kind of animation easily with processing. Let's make a program that does this. So I have this program here, which for now does nothing. Just setting the size and the color and removing the borders. And I'm gonna draw an ellipse somewhere on the screen. For example, like this. So let's see our ellipse here, fine. Now, instead of using fixed values here, I'm gonna use X and Y, so we can move it around. And I have to declare those variables at the beginning, float X and float Y. And I'm gonna make them equal to 0 at the beginning. So now if I run this program, we just have this circle at the top left corner. So now we know how we could draw this ellipse at the mouse position. It's very easy. We just have to type X is mouse X and Y is mouse Y. And if we run this program, well, we have here like a drawing program because I didn't add here the background call, background to 55 to make it white, for example. And there is the circle, whatever the mouse is. So what we are doing here is saying that our X, like the position of the circle, is the destination. We want it to be exactly at mouse X now. But what if we do something like here? If this is our circle and here is our mouse, we just want to put it in the middle of the two. Always find the position that is between where we are and where we want to be and draw it there. A function that does this has a funny name. It's called lerp. And lerp takes 3 parameters. So you enter first, where are you, or which is the first number, X, and where do you want to be? I want to be at mouse X. And the third number is where in between those two do you want to be? It's a number between 0 and 1. So if you enter 0, you don't go anywhere, you stay where you are. This would be the 0 here, and this would be the 1. So you start at 0, you end up 1, you want to be in the middle. So let's enter a 0,5, which is the middle point between those two. And I'm going to do the same here with the Y value. Lerp Y mouse Y. So we want to find the position, one position between Y and mouse Y. And this position should be exactly in the middle of those two. Let's see what happens now. So you can see the circle is following the mouse, but still not very obvious. Let's make this number smaller. Let's type 0,1. So now it's very obvious that the circle is not exactly where the mouse is, but always moves in the direction of the mouse. It always gives a step of 10%. So if X was 0 and mouse 100, we would get a 10. You can do some tests to see how this works. We can type here print lerp between 0 and 100 and 0,1. Let's test a few cases. So now we're gonna get 1 point between those two values. We're gonna get a number between 0 and 1 that is near the first one, near the 0. So I run the program and I get a 10. If I type 0,5, this is exactly in the middle. Now I'm getting 50. 50 is the middle point between those two. If I type 0.9, then that's almost at the destination. And the cases of 0 and 1, which are not very useful, we will get either the first one or the last one. So now it's 0, we get 0, and if I type here 1, then I get the second number, I get our 100. So now when I'm typing here this 0, 1, we are doing something similar to what we did here, but instead of finding always the middle point, I'm finding always a point which is near the beginning. So this is where I am now. So from here to here again, I divide this by 10 and I take one step. So now I'm here. At the beginning, these steps looks very similar. But imagine when we are almost at the destination. If now I divide this by 10 and I take that step, this step is so small. You can see this is very much smaller than this one. So the distance between these two lines is much smaller than the distance between these two lines. So the steps become smaller and smaller as we approach the destination. And it makes a very nice effect. Objects in real life rarely move at a constant speed. For example, that would be if we used x equals x plus 2 and y equals y plus 2. This is a constant speed. Each step is always the same. It's 2 pixels. And you can see it's here moving at a constant speed, which is kind of boring. It's much more interesting to have animations where the speed is varying over time. For example, like this. So now you know how you can use the lerp function to find a number that is between two other numbers and at a specific point between those two. Near the first, near the second, in the middle. And as we have seen, we can use that to do an animation where the object is reducing speed approaching the destination.